I want to talk about multiplication and division with regards to complex numbers. All right, so let's say that we had two imaginary numbers, like let's say 2i times 3i. Okay, and so what we can do is we can combine we can combine the 2 and the 3, multiply those together, and then multiply the I times itself. That'll give I squared. And so 2 times 3 is 6. I times itself, remember, that's the square root of minus 1 multiplied by the square root of minus 1, which is defined to be minus 1. Okay? And so this product gives minus 6. All right. Now, what if you had a complex number that had a real part in addition to an imaginary part? So if we had something like 2 plus 3i multiplied by, let's say, 1 plus 4i, then we just use our normal rules of FOIL to multiply two binomials, two parenthesis blobs like this together, and then it's just that when the products will involve imaginary terms, all right? But otherwise, it's the same as what you did with a similar situation without complex numbers. So when you FOIL this out, you get 2 times 1 for the first, and then 2 times 4i for the outers, and 3i times 1 for the inner, and then for the last pair you get 3i times 4i. Okay, and then so each one of those products can be done similarly to how I did the last example. So 2 times 1 is 2, 2 times 4i is 8i, 3i times 1, that's 3i, and then on the last we have 3, we can do the 3 times 4 to get 12, and then I squared gives minus 1. Okay, so that whole thing will simplify to minus 12. And now we can combine like terms, so 2 minus 12, put those together, and we'll do the 8i plus 3i. So all of this boils down to, in this case, minus 10 plus 11i. Okay? And so all the multiplication examples will be like this. Whether you have decimals, fractions, negative numbers, you just FOIL it out. You just do the distribution like you would if you didn't have complex numbers, and then all the little pairs, all the little products that you'll have, those you use your complex number rules for those multiplications. All right. Now, let's talk about division. All right, that one is takes a little more care. Suppose I had a complex number and I wanted to divide it by another complex number. Let's say 1 plus I. Now, how in the world are we going to interpret that? All right, before I tackle that situation, let me suggest that if we were dividing by a real number, maybe that would make a little bit more sense. For example, if I had 10 plus 12i and I wanted to divide that complex number by 2, you can see that it would make sense to define it as this equivalent to the two fractions 10 over 2 plus 12i over 2, which is what it's equal to, and so 5 plus 6i. All right. So in other words, if you divide by a real number, a complex number by a real number, you can use the rules that you would normally use for fractions to split it up into two fractions, and then for each one you can simplify those. All right. All right, so but that still doesn't answer what we do when we multiply by, or when we divide by a complex number. All right, what I'm going to do for the left example is I'm going to turn it into an example like the right. I want to make the bottom to be a real number because that is apparently makes more sense to us. All right, how in the world am I going to turn the bottom into a real number? Well, I can't just willy-nilly change it to anything I want. However, we know from algebra that we're allowed to multiply the top and bottom by any fraction by the same thing, okay, as long as it's not 0. So in this case, what I'm going to do, and you'll see why when I'm done, I'm going to multiply it by 1 minus I. Okay, so we just learn how to do multiplication. So go ahead and FOIL the top and bottom products out, and you might want to pause the video to work it out, but I'll tell you what I would get if I did it so in a minute. So the top would be 2 minus 3i squared plus 3i minus 2i, and the bottom would be 1 minus I squared plus I minus I. Okay, and so that simplifies, the top simplifies to 5 plus I divided by 1, excuse me, to 2. Okay, which you can stop there, or you can rewrite that as 5 halves plus I divided by 2, or 1/2 I. Take your pick. All right. Now, notice that that I was able to get rid of the imaginary part on the bottom. Okay. Why? Now you can, if you multiplied it by a random complex number, you wouldn't get rid of the imaginary part on the bottom. Okay. What you need to do to get rid of the imaginary part, is you have to multiply it by a different complex number that's similar, that's the same, except for the fact that the coefficient of the I has a different sign. All right. So here I had 1 plus I. And so I multiplied it by 1 minus I. And of course, then I had to multiply the top by the same thing. Okay? When you have another complex number that the only difference is the sign of the coefficient of the I, that's called the conjugate, or the complex conjugate. Okay? All right, so if you multiply the top and bottom by a conjugate, that's the way to do complex number division. All right, let's get some more practice finding conjugates, just so that it's clear that you know what it means. So let's say I had 3 plus 5i. All right, what would be the conjugate of 3 plus 5i? Well, you change the sign of the coefficient of the imaginary part, so 3 minus 5i. What if I had 4.2 minus 3.1i? All right, change the sign of the coefficient of the imaginary part, so that would be 4.2 plus 3.1i. All right, so hopefully that's clear. And so multiplying by the top and bottom by the conjugate of the denominator, and you'll be able to do complex number division.